Okay, we're going to start with the part 2 questions. Page 10, 11, and 12. This is what the next piece of the video is going to cover. Pages 10, 11, and 12. All right, so the question says we want to solve this system of equations graphically. All right, so graphically means we're going to put it on a coordinate plane. All right, and if we take a look at it, we see that x's are to the first power and y's are to the first power. So basically they're asking us to graph two linear equations, two lines. All right, so the way we do that, if you remember, is we want to number each of the equations, and then we want to bring them and separately and show work that we want to try to do to get the equation in the form that we want. So there's equation 1, here's equation 2, y equals negative 2x minus 1. Remember our goal, I'll put it up top here, is anytime we're graphing something that's linear, we'd like to try to get it in the form of y equals, mx plus b. Okay, so this second equation is already in that form. So I'm going to make sure I'm going to do whatever I can first and get that down before I start to get into something that might be a little bit more complicated. So let me get all the points that I know I can get right away. So I know here that m is going to be negative 2, and write that as a fraction over 1, and my b, which is my y-intercept, is just going to be a negative 1. All right, so that's what I'm going to try to graph. So I go to my coordinate plane, and I'm going to make my y-axis and my x-axis. And again, if it's not made for you, please take your time to do that. So we have a vertical line all the way through the plane with arrows on the end, and I'm going to label this my y. And our horizontal line, which is our x, all the way through the coordinate plane, and we'll label this my x. Okay? So now we want to graph this equation up here, and we start off with the y-intercept. So the y-intercept is negative 1. That's going to be a point that's on the graph. And then from that point, remember the slope. It's always the y's on top of the x's. So I'm going to make a plus 1 change in the x, followed by a minus 2 change in the y. So plus 1, minus 2. There's another point on the line. A plus 1, minus 2. There's another one. We'll do it one more time. You can see all 4 points there line up nicely. It's an equation, so we're going to line up those points with our ruler, draw a good line all the way through the coordinate plane, arrows on the end, and remember we're not done until we label. Y is equal to negative 2x minus 1. And now we got full credit for that line. Okay, I'm going to move on to the other one. And the other line, we're trying to get y by itself. So if I want to get y by itself, we're going to subtract the 4x, which I'm hoping is going to be a very easy step for you. The next step is a little bit more complicated. So I get negative 2y is equal to, again, the x's should be written first. Don't have to be, but it's in the form that we want. And then that's a positive 10. All right, now, I want to get y by itself, so I'm going to divide by a negative 2. I have to divide each of the pieces on this side by that same negative 2. Everything must be divided by negative 2. So y is going to equal a negative 4 divided by negative 2 is a positive 2x. A positive 10 divided by negative 2 is negative 5. So I'm all set. My m is 2 over 1, and my y-intercept, negative 5. So I go down on the y-axis to negative 5. 1, 2, 3, 4, 5. I draw a line, put a dot. And then remember, again, this is my y, and this is my x. So a plus 1 in the x, a plus 2 in the y. We see that point of intersection, which is good. I keep doing that plus 1, plus 2. And I'm all set. Take your ruler. Again, don't get too excited. The fact that you see this, make sure you finish this line completely. So a line all the way through the coordinate plane. Label that line, the original equation. So I'm going back up to 4x minus 2y is equal to 10. All right, my solution is right here. The coordinates of that point, 1 in the x, 1, 2, 3 in the y, negative 3 in the y. That's my answer. Put a box around it. And of course, I'd like to see a check. So we're going to check that answer, 1 comma negative 3. You're going to write both equations down for x. Move this up so you're going to see it all. Minus 2y is equal to 10. And the second equation, y is equal to a negative 2x minus 1. Plugging in 1 for x, so 4 times 1 minus 2 times a negative 3, that has to be 10. Finishing this side, 4, a negative 2 times a negative 3 is a plus 6, that has to be 10, and 10 is equal to 10, so we're good. Coming over here, plugging in a negative 3 for y, and a 1 for x. Negative 3 is equal to, a negative 2 times 1 is a negative 2 minus 1, and a negative 3 is equal to a negative 3, and we're good. So that's it. You see all that work? That's all it is, graphing two linears. Alright, now, what I want you guys to see is, let's say you wanted to do this on the calculator, just so you can see it on the calculator. Alright, so you can see what buttons to press. Zoom in a little bit more here. Okay. Alright, so what we're going to have to do, no matter what, is we're going to have to still get y equals, or y by itself, no matter what. So we hit y equals gets us to this, and we're going to plug in the two equations we got once we had y solved for. The first one turned into 2x minus 5, and the second equation turned into negative 2x. It was the same equation. We didn't have to change it at all. So negative 2x using the negative sign. Negative sign is right here. So use that negative sign. And then, where are we? Minus 1. Subtract 1 now. Alright, so that's it. If you want to see the point of intersection and see the graphs, you can go zoom. And then Z standard takes everything to negative 10 and positive 10. And you can see both of the graphs mapped out. And you can see that it looks just about exactly the same as, you know, what we had here. If you wanted to see a bunch of points that you can graph, remember it's table set, so second and then window, and it shows you, okay, we're going to start at negative 3, that's what it means, and our change in our x, normally it's fine if it's 1, so we'll make it a 1, and then you go up to table, so then second table, and you can see all of the points. Remember, y1 is that 4x minus 2y equals 10, and the y2. So we can move down, because I think we started at x equals 0. So when x was 0, we got a y-intercept of negative 5 and a y-intercept of negative 1. That's where we started. And then when x is 1, we get the point 1, negative 3 on one of the graphs, and we get the point 1, negative 3 on the other graph. That was actually our solution. So you can plot all these points if you want to, 2, negative 1, and then 2, negative 5. All right, and you can see, if I go to the graph, here's 0, negative 1, here's 0, negative 5, here's 1, negative 3, here's 2, negative 1, and here's 2, negative 5. All right, if you went to 3, you have the point 3, 1, that's this point here, which is on the red graph, and you have the point 3, 1, 2, 3, 4, 5, 6, 7, 3, negative 7. Right? So you can use the table and actually do it as well. But they're linear equations. You should be doing them the way we did them in class all year, which was just y-intercept form. Okay? That's all the work you need to show for that one. Next question is taking the same type of problem, but this time they want you to solve it algebraically. So whenever you're trying to solve something algebraically and you have your x's lined up and your y's lined up, the best way to do that is through the elimination method. So remember, through the elimination method means we want to try to get one of the variables, either x or y, to have the same number in front but with different signs. So I'm going to rewrite the problem. I have 3x plus 2y is equal to 4, and I have 4x plus 3y is equal to 7. And what I'm going to do is I'm going to elect to eliminate the y's. So I take a look at the 2 and the 3, and I ask myself, what's a number that 2 and 3 go into evenly, or what's a common multiple? And that answer is a 6. So I'm going to want to put a 6 in front of these y variables. So to get a 6 in front in equation number 1, I'm going to multiply by 3. And in equation number 2, I'm going to multiply by 2. But if I multiply by a 3 and then a 2, they'll have the same sign. So I'm just going to make the 2 negative. All right, let's see what we're going to get. I multiply the whole first equation by 3. That gets me 9x, and then plus 6y, and then equals 12. That's all of this, that, and then that, and then that. And now the bottom equation, negative 2 times 4x, that's negative 8x. Negative 2 times 3y, that's minus 6y. And then negative 2 times 7, that's minus 14. I draw my line. And now I add the two equations together. When I add them up, 9x minus 8x, that's x. The y's will cancel, equals 14 and a negative, 12 and a negative 14, it's a negative 2. So there's my y answer. Okay? Then I pick one of the equations. I'm going to pick 3x plus 2y is equal to 4. And what do I know? I know that x is equal to a negative 2. I'm going to take that negative 2 and plug it in, showing all the work. Notice I wrote the equation down. Now I'm going to plug it in without doing any mental math, just seeing it. And now I'm going to start doing some math. 3 times negative 2 is negative 6, plus 2y is equal to 4. And now I'm going to try to get that y by itself. I'm going to add the 6, so I can zero that out. I get 2y is equal to 10. Then I'm going to divide by 2, so I get y is equal to 5. Okay, remember, you're solving a system, so your answer is going to be taking your x and your y at the same time and writing them in a box. Or you can write it as an ordered pair. Check. Well, I want to check what? X equals negative 2 and y equals 5. And if you remember the way we did this in class, check to see whatever the last equation you used was, which was 1. So I just really have to check it in equation 2, which is that 4x plus 3y is equal to 7. Plugging in negative 2, we're going to get 4 times, just showing the work. Don't do any mental math yet. 3 times 5 is equal to 7. Now I can do some math. That's negative 8 plus 15 is equal to 7. Negative 8 plus 15 is 7. And there's your check. All right, so that's that one. That's, again, solving algebraically. Last one for this video is we have a system again, and the system is the system that is going to consist of, if you take a look at it, you have an x squared term, so that's going to be a quadratic, so you can have a parabola. And again, take a look at the sign in front. So this is going to be a parabola that smiles, right? And then this is going to be, y to the first and x to the first. That's going to be linear. All right, so we'll mark this equation 1. Equation 2, I'm going to bring equation 1 over here. Y equals x squared minus 6x plus 1. I'm going to bring the linear equation over here. Y plus 2x is equal to 6. They already give you the x and y axis, which is great. You don't have to draw it. Everything's labeled for you with that. I'm going to graph the linear first because it's the easier one. And as I said before, let's get the points. Y equals negative 2x plus 6. My slope, negative 2 over 1. My y-intercept, 6. So I'm going to start at 6. 1, 2, 3, 4, 5, 6. That's this point right here. That's the y-intercept. And remember, this is my y, and that's my x. So I got a plus 1 and then a minus 2 in the y. Plus 1 in the x, minus 2 in the y. Plus 1 in the x, minus 2 in the y. Plus 1 in the x, minus 2 in the y. This is your linear line, so take your ruler, solid line all the way through the coordinate plane. Remember, arrows on the end, and then label. The original, y plus 2x equals 6. All right, you get that one done and out of the way. All right, next one is your parabola. Now, for your parabola, you're going to have to set up a table of values. All right, so how do your table of values work, and how do we use or help, how is the calculator going to help us get that? Well, we're going to set up a table. There are going to be x's that we're going to plug in, and we're going to come out with y's. And we have y equals x squared minus 6x plus 1. All right. Where we're supposed to start, if you remember, is we're supposed to find out where the axis of symmetry is. The formula, minus b over 2a. All right. If you remember, we always started these problems by labeling what a, b, and c is. A is going to be the number in front of x squared. That's a positive 1. B is going to be the number in front of x. That's a negative 6. And c is going to be that constant, the number that has no variable to it. All right, minus b, so it's minus a minus 6, so that's a positive 6 over 2 times 1. So we're going to get x equals 3 as an axis of symmetry. Well, that means we're putting the 3 right in the middle of our table. And I'm going to want to see where a 2 goes, I'm going to want to see where a 1 goes, and I'm going to want to see where a 0 goes, and on the other side, I'm going to want a 4, I'm going to want a 5, and a 6. Alright, so those are going to be the x values. So now how do we get everything plotted? Okay, well, in the calculator, you can either take each of these x values and plug them in and come out with the corresponding y's. So I can show you that real quick. Y is equal to 0 squared minus 6 times 0 plus 1. So that's 0 minus 0 plus 1. That's going to be 1. I should have an xy column here too as well. So I'm going to get the point 0, 1, and that's going to be on my graph. 0, 1, that's on my graph. I plug in 1, y is equal to 1 squared minus 6 times 1 plus 1. 1 squared is 1. Then minus 6, that's a minus 5. And a negative 5 plus 1, negative 4. So I get the point 1 comma negative 4. So 1, 1, 2, 3, I'm down here, negative 4. Okay? So we can keep going. What we're going to do, though, first is rather than keep going in that route, I'm going to show you how to do it on the calculator. So here's the calculator again. And the way this works, again, turn it on. Let's go to y equals, clear out anything you had there by going to the line and clearing out. And now I'm going to type in that equation. So it's x, and then here's x squared, then minus 6x, and then plus 1. So that's in. Second, quit. And now I'm going to go to my table set. The table set, which is second and then window. And how do you have the table? Well, I got to make sure I have 3 in the middle of it. All right. And if I go back 3, I'm going to start at 0. So that's what it says. Table set, we want it to start at 0. And we're going to have it increase by 1. So we're all ready. Go second and then graph. And here's my table. So as you can see, we have the point 0, 1. And then we have the point 1, negative 4. All right. The next point, we can just put them into this row right now. We can put them in both rows. We have 2 and then negative 7. So we get the point 2, negative 7. And then we get the point 3, which is our axis of symmetry. So this will be our turning point. 3, negative 8. And then 4, and we go back to negative 7. So we've turned. We're coming back up now. 5 and negative 4. Notice how we're repeating our numbers now. And then 6 and 1. All right, so now we're going to graph those points. So here we go. Those are the 2 points I have already graphed. That's this one and this one. So now I'm at 2, negative 7. 1, 2, 1, 2, 3, 4, 5, 6, 7. And then 3, negative 8. And then 4, 1, 2, 3, 4, negative 7. And then we have 5, negative 4. 3, 4, 5, 1, 2, 3, 4. That's a point of intersection. And then we're at 1, 2, 3, 4, 5, 6, 1. All right, we might have to bring this one out a little bit more because we got to find out where that other point of intersection is. So what I'm going to do is, if you take a look, I'm going to go back. So I'm going to go arrow up from the 0, and I find out what's going on at negative 1. So I have negative 1 and then a positive 8. Negative 1, 1, 2, 3, 4, 5, 6, 7, 8. There's our other point of intersection. right? So this graph is going to come down. This parabola is going to come, let's do it in green. This parabola is going to come down, hit this point. Make sure you don't draw it as a V. Remember, it's a curve. So we're curving it in and then curving it up and through. Okay? And then make sure you label it. Y is equal to x squared minus 6x plus 1. We're solving the solution, or we're solving it, so circle the points of intersection. Make sure you put them down. We have one point of intersection at -1, +8. We have another point of intersection at 1, 2, 3, 4, 5, -4, and this is my solution. Okay, that's it for that part.